So let me get right into the subject, and I don't think I need to tell an audience like this, but it's worth conveying why space travel is an extreme challenge, especially the space travel for humans, getting us out there. It just starts with the scales of space. So let me just give you the handy scale model, something that you can use, next time you're in a supermarket and in a long checkout line, you can regale the person behind or in front of you in the line with scale models of the universe, and at some point they'll start to look at you rather strangely, but it's a way to occupy time. So you have the Earth to the size of a walnut, the Moon a pea at arm's length, and on this scale, the Sun is, across the courtyard, 100 meters away, a 3-meter ball, and the solar system is to the periphery of Los Altos, our little town that we're sitting in. And what matters is that the nearest star is not even on the Earth. It's 30,000 miles away. So that gives you a sense of solar system scales compared to interstellar scales. And you can understand right away, without wanting to pour cold water so early in the talk, that all the Star Wars, Star Trek fantasies of interstellar travel are going to be extremely challenging with distances of this scale. Also, to give a little perspective, if you want to go to the stars, remember that this little journey, this from the walnut-sized Earth to the pea-sized Moon, in current dollars, this cost about $70 billion to get 24 people there. So it's also expensive. It's hard and it's expensive. So that's a context. But let me go back at the beginning, at least, to why this is even interesting, or really more fundamentally, why we do it. And to reference this, I'm going to show you an amazing map that's emerged from research of the last few decades, which reveals through genetic analysis of existing populations on the Earth how we moved across the planet after leaving Africa. And so you can see the trajectories of how we radiated across the planet to all the continents. And what's striking is this took very little time at all. Look at the time, the couple of thousand of years between going across the land bridge of the Bering Strait, because there was land, you could walk from Russia to Alaska, all the way down to the southern tip of Patagonia, a few thousand years. So this is an extraordinary human migration in a few hundred generations. And remember, hunter-gatherers, small nomadic tribes, bands of 50 to 100 people living by their wits with no technology, that's an extraordinary migration. There are animals that obviously travel large distances and migrate, birds particularly, but other species, whales and so on. And they do it with the rhythm of the seasons, and sometimes they do it for food sources. But humans are the only species that have migrated across the planet with no immediate need to eat. They're doing it out of curiosity. Of course, I look at this graph, especially the move across the Americas, and I notice that, in the middle of this migration from the cold of Alaska to the bitter cold of Patagonia, they actually came somewhere around here. They went through Southern California, Northern California, and I'm sort of thinking, why didn't they just stop there and say, this seems kind of nice, we'll stay here? No, they just were driven by curiosity to go further. The research now is interesting because genetic analysis of these same existing human populations shows a correlation in this graph. This, for science, is a reasonably good correlation between the incidence of an allele or a variation in one particular gene with the amount of thousands of miles that different hunter-gatherer groups or modern nomads have traveled in their journeys. And so what it's showing is that this variation of a single gene correlates with the amount of migration. And this has been dubbed the explorer gene because of this. This gene also correlates with certain other aspects of human behavior. It associates with ADHD behavior, with risk-taking. If you surveyed people who do, use wingsuits or jump out of planes or parachute, you'll find a higher incidence of this gene. So this is an interesting genetic component to the exploration urge, the itch we have to explore, saying that it has a genetic basis. Now, I'm not going to pretend to reduce genetics to one gene and say that this is the reason we explore and other animals don't, and that we do this because we have to. but it's pretty intriguing research, and it becomes a basis for our exploration of space. We've explored the planet almost as much as we're able to, and that itch to explore continues. It remains. It's built into us. I'm not going to give a history of the space program. I want to talk about the present and the future for the most part, but I'll just mention a few landmarks. The first putative astronaut was Wan Hu, a minor functionary in the Chinese dynasty of sort of Shakespeare and Leonardo's time, actually. On a command from Wan Hu, 47 servants walked forward with matches and lit 47 large fireworks attached to his bamboo sedan chair. And according to Chinese legend, Wan Hu became the world's first astronaut. In practice, of course, Wan Hu died a hideous and horrible death. That's not how it's written up. But he wanted to explore the stars. So this desire, this urge to explore goes back a long way. And when it's hard to project how this will change, I'm going to use this example for the difficulty with which we can project forward in time, because look at that little rocket of Robert Goddard in 1926. The rocket, most of that is the frame. The rocket is the little thing on top. It's a liquid rocket fuel, the same kind that we still use today. And in 1926, it traveled 132 yards across a frozen cabbage patch of his Aunt Effie's farm. And that was it. That was the beginning of space. And it's hard to go and project from that to getting to the moon. But that's how it starts. It starts with the visionaries and the pioneers. And then another unsung hero. I want to pick out unsung heroes, in this case a heroine. Miss Baker, a spider monkey, was the first primate in space in 1959 at the dawn of the space age. Miss Baker survived. Some of the animals first sent into space did not survive. Miss Baker survived and lived to the ripe old age of 27, which is old for a spider monkey. And Miss Baker was buried at Goddard Space Flight Center with essentially military honors, and 3,000 people went to Miss Baker's funeral, and I think any of us would be lucky to have 3,000 people at our funeral. And then, of course, we recall that the early history of the space age and the space race was a rather strange history, and it sort of belies this sort of noble genetic urge to explore that's present also in the science fiction and the popular culture. Really, the space race started out of the depths of the Cold War and a geopolitical pissing contest between the two world superpowers. And those of you old enough to remember will realize that the United States lost at almost all of the first landmarks. The Russians were the first to launch a satellite, Sputnik, which scared people enormously. Even though it was far too small to possibly hold a nuclear weapon, it raised the specter of nuclear weapons in space. And remember, this is the depth of the Cold War when nuclear weapons were being built at a huge rate. The first man in space was, of course, a Russian, the first woman, the first spacewalk, and you can go down the list. So for most of the first decade of the space program, the Russians were essentially kicking our butt. Things changed, but the backdrop for the space race and the intensity of it was this rather awkward sort of military rivalry with a superpower. Here are the words of Alexei Leonov from the very first spacewalk in 1965.
It was an extraordinary sensation. I had never felt quite like it before. I was free above the planet Earth, and I saw it was rotating majestically below me.
Now that's in retrospect and in hindsight, but in the moment, Leonov nearly died 3 different ways. His spacesuit malfunctioned, and when they got him out of it, he had sweated to the point where it had filled his boots up above the ankle. The airlock malfunctioned, and he was within a few seconds of not making it back alive into a space capsule. So this was dangerous stuff back in the early days. But what an extraordinary feeling or sensation to be the first person above the planet, hovering, weightless, looking down on the whole thing. We also recognize that with the benefit of hindsight and with the mythologizing of Hollywood and the media, some of it takes on a mythic tinge, and you'll see this very clearly in the next movie clip from a movie that I'm sure you're very familiar with, but try and look at it through the lens of how the space race started and how we sort of tell the stories looking backwards. So there is a mythic quality there. It's a bittersweet story, of course, because Apollo 13 was a failure. Those astronauts never set foot on the moon as intended, and they limp back home barely with their lives. And those of you, again, who can remember will recall that the last 3 scheduled or planned Apollo missions never happened because the budget was cut back and they were canceled. So the public's attention span on the Apollo program actually lapsed, and there was another reason for that I'll get to. But the strange thing is that we live in a situation where this has become a dim cultural memory because it is so long ago. Gallup polls show clearly that about 7% of the 7 to 9%, depending on the poll, of the American public don't think that it happened, that don't think that we went there, think it was a conspiracy theory, that we're making it up, that it was faked by NASA. And that's a very strange thing. As an educator, I'm torn on that one because part of me gets extremely pissed off to think that people will be so willfully ignorant about something that is essentially humans' greatest technological achievement, period. On the other hand, if I think of a list of the batshit crazy things that 7% of Americans believe, you know, Kennedy, conspiracy theory of Kennedy, Elvis, we saw him in the supermarket 3 weeks ago. At the 7% level, people believe so many amazing and weird and crazy and obviously wrong things that maybe you shouldn't get all bent out of shape out of it. So obviously when I teach, I try and show that there is still evidence left behind on the moon. We've been doing geological experiments with reflectors that show the moon is getting this much further away from the Earth every year due to gravitational interactions, and the Earth is giving an extra microsecond to your year, which you should make good use of. It's extra time caused by gravity. So we definitely went there. But if you're going to question it, it's fine. You can question it in public or with your friends or your family, but just don't question it as this Dutch filmmaker did in the face of someone who actually set foot on the moon, one of only a dozen people to do so.
You're the one who said you walked on the moon when you didn't. Calling the kettle black, if ever thought of it. Saying I misrepresented myself. Get away from me. You're a coward and a liar and a thief.
So yeah, don't mess with an astronaut. I mean, Buzz is 5'8", Bart Sibrel, the Dutch filmmaker, is 6'7", but you know, he totally clocked him. Again, only 12 people have ever stood on another world. That's worth bearing in mind when we're thinking of the grandeur and the achievement of the space program. This is a very select group. But we have been in space, and a much larger number of people have experienced the majesty of zero gravity and seeing the Earth below them, suspended in its full glory. So let's look at the state of space, and then let's play it forward into the future. The state of space now is that it's a little early to judge. I'm trying to take a historical view here, and we should remember that it's about half a century old. Human technology, the Industrial Revolution, is 7-8 times longer than that. Human civilization is 10-12,000 years old. So we have to judge it in the framework of these major epochs of human evolution. And most of it, as I mentioned, was for most of the time the work of two countries engaged in a bitter political and military rivalry where the activity was not really being done for altruistic purposes or for the purposes of pure exploration. The number of people in orbit is still around or just under 600. 10 times more people have stood on Everest. Don't take it off your bucket list. That's not that big a deal to climb Everest. Being in space, zero gravity, that's a big deal. 600 people. Leaving the Earth's gravity, 24. Setting foot on another world, 12. I was lucky enough to give a talk at Space Fest outside Tucson 2 years ago, and they had 9 moonwalkers there. 2 are dead. Neil Armstrong was still alive but didn't do that kind of thing. And so all the other 9 were there. And to be in one room having lunch with 9 people who stood on the moon, I mean, you know, I don't get gaga very easily, but that was amazing. So that is a very special club. But it's a long time ago. As I said, people forget. People don't think we went. They don't think it's important. They don't think it's relevant. It feels like an anomaly. And there's the problem of how we may have lost our way in space. The biggest major investments the United States has made in space over the past few decades have been the space shuttle and the space station. The space shuttle, which is retired now, 6 years, is a half-century-old technology. It was ancient technology at the time it retired. And as we know, 2 of the 5 orbiters were lost with all hands on deck in horrible disasters that shocked the nation. That's not a very good failure rate. The military gave up on it years before then. It was supposed to be a space truck that would go out once a week, 50 times a year. It never had more than a dozen or so launches in a year. So the space shuttle never quite lived up to its promise. The space station was supposed to cost about $8 billion in 1984. It's now probably well over $120 billion. The companies that were supposed to flock to it to do pharmaceutical research and zero-gravity research don't want to do it unless it's so heavily subsidized, it's almost giving it away. Scientists don't really want to use it. It's not a good platform for doing astronomy. And so the space station has been a demonstration that we can operate in space, pretty mundane stuff, mostly plumbing and electrical work. But it's not, again, very exotic. It's not very exciting. And a lot of people, even in my community, consider it international pork. So these are 2 big price tag items that have occupied the attention not just of the US, but of a lot of the world in space for the past few decades. It doesn't look that shiny. And so the question is, where are we and where are we going? What's going on with the space program? And part of the answer is simply fiscal. This is NASA's budget in constant dollars, in dollars adjusted for inflation, and it shows just how anomalous the spike that funded Apollo was. And you can also notice, if you look at the graph, NASA's budget was going into reverse even before the first moon landings happened. Because, as you know, in 1967, when the moon landings were planned and the final 3 were going to be canceled, America was about to enter a ruinous and expensive war in Vietnam. And Johnson, a very strong supporter of the space program, just realized we couldn't afford it. And so NASA's anomalous budget of 4.5% of GDP was never sustainable. What's a little more discouraging for acolytes and fans of space is that slow decline from about 25 years ago from 1% of GDP to 0.5%. So NASA's budget has declined a factor of 2 in real terms just in the last 20 years, and that's hard. So NASA gets dinged for all sorts of things, lack of vision, lack of imagination, but you try doing ambitious, difficult, and expensive things with half the budget you had 20 years ago. Not easy. So that's a context for what's going on too. And of course, we all know, I don't want to get political here, but we all know that when it needs to be, we spend money on things. There's NASA's budget at the top from about 8 years ago, and there's the Wall Street bailout, which was 50 times NASA's budget. So you could have funded 50 years of NASA's dreams going forward. We could have had colonies on Mars and the Moon easily if that money had just gone into a different pot in the federal budget. Okay, I know that's naive, I know that's not how it works, but it's just a matter of context, right? You spend your money on the things you want to spend your money on. I mean, NASA has other problems because its press is not always positive. Tends to be that NASA only gets into the news because they need money or because something blew up. That's not usually a good situation to be in, to be getting your media that way. Something that you may not be as aware of, because it's been happening a little bit by stealth, and it's a semi-secretive program in the depths of the military-industrial complex of China, is that Chinese space program is moving by leaps and bounds. And the bottom line here is, again, budget. China's economy, until it tapered off a little in the last couple of years, was growing at 8 to 10% a year for almost 2 decades. That doubles your budget every 5 years. And the space program in China was growing at the rate of their economy. And you can compare that to the NASA graph I've already showed you. So from a very small start, China has developed a very fully fledged space program. And in the West, people denigrated it originally. Oh, they're just copying American technology. They're not very original. They can't do anything impressive. That is simply not true. The average age of a NASA engineer is 57. The average age of a Chinese aerospace engineer is 27. They have young talent. They're developing their own ideas. Their Long March rocket involves new technologies and innovations not present in any US or Russian rockets. And so they have, and you can see the density of tick marks at the top, how their number of launches is going up almost exponentially. That's sort of unsustainable, but they're doubling every year. They have plans for a space station, their own space station, at a time when the International Space Station may be deorbited by a lack of funding commitments. They have plans for going to the moon. They've already been with a rover, of a moon base, a Mars base, and of course, lurking behind of a real concern is the possibility of militarization of space. The Outer Space Treaty of 1967 is the only UN treaty that all the main superpowers signed, and it supposedly demilitarizes space. But if you cede that high frontier to another superpower, especially one that you're not necessarily getting on well with, and especially one whose space development is heavily buried and attached to their military budget, then there's an issue. And by way of contrast, I'll mention something about NASA that, again, most people don't know. When NASA was started in 1959, there was a choice. The military were pushing strongly for NASA to have a military function. There was a strong resistance to a civilian space agency, and it was Dwight Eisenhower, president of the time, and of course a general, who resisted that. And he insisted that NASA's charter have a civilian mandate, have openness, accessibility of records. Now, the space shuttle did launch military payloads, and they were secret, but basically NASA's been a civilian and open public records space agency, and we have Eisenhower to thank for that. That was a very important decision made right at the founding of NASA. In China, it's not the same thing, and we literally do not know all the things they're doing. But the more optimistic, that's slightly ominous, if you like, or somber, but the more positive and optimistic piece that's new on the landscape is, of course, the private sector, and I want to talk significantly about that. And again, it had its start in a way that might not lead you to project this to anything magnificent. Up until 7 or 8 years ago, there had only been half dozen or so space tourists, and they'd each spent $10 or $20 million a head to have a joyride for a week in the space station taken there by a Soviet rocket, because the shuttle was, it may or may not have escaped your notice, but we're now running on 6 years when America cannot launch an astronaut into orbit without help from the Russians. And it probably hasn't escaped your notice that we're not super cozy with the Russians these days. So that's not a good situation to be in. So the first space tourists were using Russian launchers to get to the space station and paying a nosebleed amount of money. And it doesn't seem to be relevant to anything or anyone else. Charles Simonyi even went twice, and you can add, if you go out for 20 million, just reference this for your dream vacation, you can add 15 million to the 20 million and do a spacewalk as well as have a week in the space station. Nice holiday of a lifetime. But the perhaps more pivotal thing that happened in the same time frame was the X Prize. This is a brilliant idea, and it's not original to the X Prize Foundation. It, of course, was modeled on the prize that was won by Lindbergh in 1927, and the history there shows that 10 or 12 teams were competing to do that first solo transatlantic flight, and they all spent far more than the $25,000 prize that was available for that first flight. And nobody knew how it was going to go. Lindbergh was called the flying fool. He was the dark horse. Nobody expected him to win. But what happened, of course, that 1927 is an interesting date, because within 5 years, the fledgling commercial airline industry emerged, and within 10 years, commercial aviation had taken off. So the X Prize kicked into gear something that now transports close to 1 billion people around from A to B effortlessly and without thinking about it every year. That's the model. And so the X Prize was an attempt to kickstart the space program. It was won by Burt Rutan, probably the genius of aviation design of the last century, who took his skills into the aerospace sector, working now with Richard Branson. And it's a repeated suborbital flight of 100 kilometers, which is not to the purest true space, but it's the Kármán line, so it's the definition of near space. And it's truly dark up there. The Earth would look round. It would be black outside the window. So this X Prize was what really kicked a whole commercial space industry into gear. And we know what the high watermarks of it are, but probably what you're not aware of is that there are now over 25, more like 30 private space companies that are all doing interesting things in this sector. They all have business models, they all have investors, they have potential revenue streams. They're not doing it as vanity projects. The most prominent ones, of course, are the ones with the most prominent mouthpieces. Richard Branson, because he's a billionaire and very outspoken, he went from an airline, Virgin to Virgin Galactic, and he stole Burt Rutan as his spacecraft designer. Now, they've had a disaster just less than 2 years ago with the death of a co-pilot and near death of a pilot, so they've been stalled by a couple of years from their paying customers. But I think a telling fact of Virgin Galactic was that after that disaster, Richard Branson offered full refunds to all the people who'd put down a total of tens of millions of dollars of deposits for flights. It's a Hollywood A-list, as I'm sure you know, Brangelina, Tom Hanks, all these people, celebrities wanted to go up too. And I think he only had 2 or 3 takers for a refund out of thousands of people who've put the deposits down. So people know it's dangerous. The people who want to do this, even as a joyride, even as a once-in-a-lifetime thing, understand you could die. It's dangerous, and they are not deterred. That's interesting information at the beginning of a new industry. And as far as people who can afford to do this at the level of raising money and building companies, note that the number of billionaires is increasing rapidly. In the segregation of wealth in the world, where the 1% at the top have a larger fraction of the pie, there's a lot of people with the capacity to do this work. And here are some of them. Rutan is not individually rich. He's the genius designer that Richard Branson, the next one over, hired. Peter Diamandis, maybe not as well known to many people, doesn't crave the limelight, but he's the founder of the X Prize Foundation and really a genius of thinking of models for kicking this into a high gear. Elon Musk does indeed like publicity. He's Tony Stark, of course. So, and he's a true triple threat. He made his money with PayPal, and he's a tech entrepreneur. He's a very good businessman, and he was trained with a degree in engineering physics, so he actually understands how to build rockets personally. So he's not doing this. Richard Branson does not have technical training. So some of the people doing this really know what they're doing at the guts level, at the guts, nuts and bolts level. And then there are people that are newer to the game. The secretive Jeff Bezos, whose Blue Origin company has sort of come in the rearview mirror much faster than most people realize, and has started to match Elon Musk and SpaceX feet for feet. And this is a very intense and bitter rivalry now. And then, as Andy alluded to, the Yuri Milner, who's put $100 million into SETI, Search for Extraterrestrial Intelligence, has put another $100 million into sending nanobots to the nearest star system. And you're starting to get the feeling here that if you do want to be a space entrepreneur, you sort of need to have this sort of Eastern European male pattern baldness thing going, right? So if you don't look like this, I wouldn't even bother. Don't even try. So they do have designs. There are sophisticated designs for spaceships. The space tourism business is going to start taking off. Google got into the game a few years ago with an X Prize, modeled on the X Prize of suborbital flight. And this is a prize of $30 million to land a robotic small spacecraft on the moon, travel 500 meters, and send back data and images. And the timeline's at the bottom. It's a tough thing to do, and the deadline for winning the prize is actually the end of this year. It's already been postponed once. And there are still, I think, 4 or 5 teams that are viably, potentially going to win this prize. And most of them, again, will have spent more money than the prize. This is not a prize open to governments or countries or big corporations. There are student groups doing this. There are single universities doing this. This is lowering the bar for the private, for space, to the level of much smaller entities, and that's part of why it's exciting. There's Spaceport. In New Mexico, there's a spaceport that's home to Virgin Galactic and about 10 of these 25 or so aerospace companies. And they've got a sweetheart deal on setting up this spaceport. And we know it's hard. Elon Musk has suffered some setbacks, and he put the video of this one on the web the day after it happened. Reusability is the key, and you need to launch and land your rocket after expending its fuel, and then refuel and relaunch. Apollo was a hugely expensive, expendable for the most part, rocket system, and that's what makes it expensive. But Musk was not deterred. He put the video up and said, yeah, sure, we screwed up, we had a disaster. Nobody died, these are unmanned rockets. A few months later, this. It's an offshore platform, just in case there is a disaster. No populations are nearby. That is as hard as it looks. It is rocket science. It's incredible. It looks amazing, and it is amazing. This is hard. The rocket equation, to coin a phrase, is a bitch. It embeds the fuel, the initial fuel, and the eventual mass, which was mostly fuel, inside a logarithm. And that tells you how much you can accelerate in terms of velocity difference. So forget the math. That curving slope is essentially telling you that for any big rocket, 90 to 95% of its mass will be fuel. Just to haul, you're spending all that fuel energy to haul the fuel into Earth orbit, which is part of why it's so expensive. So you need to innovate. You need to make this better, cheaper, quicker. And since we're still using chemical rockets, and all the entrepreneurs that I've been talking about are still using chemical rockets, and there's been no fundamental change there, they're just trying to engineer it to death. And so here, for instance, is the cost per pound of payload or kilo of payload for almost all the launch vehicles over the last half century. And here's the place where SpaceX hopes to get with their Falcon Heavy. And they're on the way to reaching this. And of course, it's not just a combination of what it costs to get a kilogram into orbit, it's also getting a big enough payload up there to be interesting. So you also need a significant capacity. So it's a powerful rocket. And this red dot is dropping the cost per kilo by a factor of 5 to 7 on the best available now. And that's a game changer. And that's what all these companies are trying to do, because that just takes it into a new regime. It is dangerous. People will die. But once again, let me hark back to the civil aviation example. The Lindbergh Prize, civil aviation starts in the 1930s. And this is actually, you can't read the scale, but this starts at the end of the Second World War, 1946. And the little dots, the circles are just major innovations in civil aviation authority regulations, pressurized aircraft, multiply redundant safety systems. So each circle was an innovation in the FAA in terms of civil aviation. But the bottom line is that the fatality rate since the Second War has declined by a factor of 100 per kilometer or mile or journey traveled. So civil aviation wasn't that safe in the 1930s before the Second War. And it's now so safe, most people just don't think about it. And the expectation and the hope is that the commercial space industry will go through the same process. That yes, there will be some disasters and some people will die. There'll be learning curves, but eventually it'll be mundane. And all of these companies have a viable business model. But there are hazards in space. Some are mundane. So let me bring back to how this is funded. Here, this will make you feel a little poor, but here are the growth in the number of billionaires in the world. Branson and Musk have dropped a good fraction of $1 billion of their personal fortunes in this. But the number of billionaires worldwide are worth $7 trillion. And so there are dozens of billionaires who collectively, a small group of them could outspend NASA easily. That just puts it in perspective. And because many of these people are young, they've made their money in the sectors that are big around this part of the world, they're looking for interesting and high-tech and forward-thinking things to do. So I think we've just seen the start of how billionaires might spend their money. And I do a little model in my class. I teach intro astronomy to 18 millennials, 18 to 22-year-olds, and I poll them on how much of their money they would spend. I assume their earnings after graduation, and I poll them of how much they would spend for either something in the first 10 years when they're still young or a once-in-a-lifetime trip, assuming a few days in Earth orbit. And it can run an economic model. So we do it in real time with clickers in the classroom, and I run the model. And if you run that model, if you just drop down to the bottom two numbers, you're still at the top end of the population, but you're already projecting pretty reliably just from this cohort of Americans, sort of 30% of young Americans, $20 billion a year revenue. That's exactly the revenue of Hollywood in box office, DVDs, and CD sales. So you're talking about a Hollywood-level revenue stream already. And if the price per kilo goes down by a factor of 2 or 3, easily possible with what's planned by the current startups, then you're projecting revenues of $100 billion a year. That's enough to get people's attention. So this is going to happen. And I was struck by the connection with entertainment because this is for recreation, it's not for exploration and science. And so I found, as anyone would do, the only place you can find the cost of things like NASA space missions, you can't go to NASA's websites, it's too chaotic. So I go to Wikipedia, and from Wikipedia I figured out the average cost of a space mission of all types and the average cost of a movie to make it in the last half century. And the interesting thing is these curves crossed about 5 years ago. The average movie now costs more than the average space mission. So the analogy is almost perfect. And if you really want to make the analogy pointed, look inside the circle. Less than a decade ago, if you had $400 million burning a hole in your pocket, you could make a really cool movie by a director about life on an exomoon, Avatar, or you could build a telescope that went and found a couple of hundred Earth-like planets. It did the experiment. They cost the same amount. And when I'm trying to persuade people, not this audience, but other people more skeptical about science, why it's worth spending money on it, that's my comparison. Yes, you can do the experiment for the same as the cool movie, right? So why not do both? Meanwhile, less excitingly, because we'd like to think of people doing this and people being out there risking their lives and being adventurous and taking selfies in Earth orbit, what's really exciting is the miniaturization end, what's happening at the bottom. That little item being held by that hand is essentially everything that would have been in a satellite package the size of a refrigerator 30 years ago. So the miniaturization has allowed CubeSats, it's just a technology that literally fits in a standardized 10-centimeter cube, and you can gang them together and put a launch payload together where each cube may only cost $10,000 or $20,000. So once again, student groups, single universities can do this. It's not that expensive, and you launch them all together and they do their separate thing. And you can see on the right the growth, the exponential growth in CubeSats. And once you get into Earth orbit, you can attach another venerable technology, solar sails, to the CubeSats, and you're no longer bound to Earth orbit. Now you can start exploring the solar system extremely cheaply. The energy is free, it's solar energy. So this boom in the miniaturization of space orbital technology is, and of course it just goes against the history of the subject where you build a big, robust, sturdy, expensive satellite and you can't afford it to fail. It's too big to fail. Hubble Space Telescope, too big to fail, too expensive to fail. With this, you launch swarms of these things, and some of them won't work, some will burn up in the Earth's atmosphere, and it doesn't matter because they're redundant. You just put up lots of them. A lot of Earth-looking science is now being done by CubeSats, and it's very important to the health of the planet to have this kind of monitoring going on. It's doing things that the government agencies and countries cannot or are not doing. And so here is the cost per launch. This is a logarithmic scale, and this shows the three displaced curves show how much cheaper it is to have fully reusable launch vehicles. That's the enormous innovation that Musk and Bezos are trying through SpaceX and Blue Origins and others. It also shows that this gain is going to sort of flatten off at some point in the future. But if you project the cost per person to launch a person, it's going to come down from what it is. There's the Branson number, if you like, and he's not even true Earth orbit, 250,000. It's going to come down to the tens of thousands fairly quickly. And that puts it on the radar of a lot of people as an interesting thing to do. So I'm going to make an analogy, and I hope I don't force it too much, between the stages of evolution of the internet and the space program. And I'll do this quickly. You can get the gist. There's a pioneering phase where the people doing this are visualizing things that most people can't even imagine. I doubt anyone, very few people will know who that is on the lower left. That's J.R. Licklider. He worked at a government think tank, and in 1960, when a big computer would be the size of this stage, he visualized the wireless internet, data in the cloud, everything we have and take for granted. He visualized it. He talked about it in a position paper. So these were the people thinking way, way ahead. Then you have incubation by the military-industrial complex, which is important because they have deep pockets and they can support it when it's not viable. Then you have migration into the research arena. We know the first web browser came from CERN, which really just does particle physics for the most part. And most scientists, I got my first experience of emailing people who mostly worked in government labs and military institutions. Back in the mid-1980s, I was using email. Nobody knew what email was. So it comes through this process. And in the internet, we can at least put a time on when things just bust open, in the Big Bang, if you like, 1995. In 1995, a company with the weird name Amazon was founded. In 1999, two grad students not too far from here dreamed up internet search. The first internet service providers started in 1995. And I challenge all of you, because we were all here in 1995, to visualize where we would be now, starting in 1995. I don't think anyone could do that. That's hard to do. So with space, it's very similar. You have the pioneers, the Goddards, where it's very hard to go from Goddard's little tiny rocket, oxygen rocket, to the Saturn V going to the moon. You have incubation by the military-industrial complex, Wernher von Braun, secreted back to the US. These are not always easy stories. Von Braun was obviously a Nazi rocket scientist with significant connections to the Nazi Party. He ran the Mittelwerks rocket plant in northern Germany, where 8,000 slave workers died making the rockets. Another 8,000 people died in my homeland, England, from the V-2 rockets. And his Nazi record was completely scrubbed by the US military and the government because we wanted him building our rockets. That's a little awkward, but that's how it happened. So we had these people. Then it went into the research arena, and so we have NASA, a civilian space agency. And I don't know what the equivalent of 1995 is for the space program. Maybe it's now. It could be now. It could be around now. It's not quite as dramatic as the internet. But I think the same thing is happening, to the point where if we look back 20 years from now, we'll be unrecognizable. And the important other part of the analogy is that the role of civilian research, the role of universities and research institutes in the internet has not gone away. The pushing of the envelope of supercomputers and quantum computing and high-speed internet and fiber is still happening in research institutes. So that doesn't go away. It just means that the commercial enterprise starts to dwarf everything in volume of activity and value. And I do think it's happening now. This is the plot of overall, globally, worldwide, the number of spacecraft of any kind launched into orbit since the beginning of the space age. And what you'll see is that 2 years ago, for the first time, most of the launches were commercial. That's never happened before in the history of the space program. It is happening now as we speak. So I will, therefore, be bold enough to say that I think the Big Bang is happening right now. So let me get to the last part of my talk and talk about the future. What do I think is going to happen and might not happen? I mean, we could be grandiose and excited about what might happen, but space is still hard. Don't forget the rocket equation. Physics still governs all of this stuff. I think we're going to see the moon, of course, through the Google Prize. You know, the Treaty of the Moon, there were two treaties. There was the Outer Space Treaty of '65, signed by most of the world's superpowers, luckily, because that's demilitarization, that's no nukes in space. There was the Treaty of the Moon, which actually addressed ownership of space, ownership of asteroids and the moon and all that. And only 4 countries signed it, and the major superpowers did not. So you're going to see commercialization of space. You're going to see people claiming to own things. NASA's already twitchy because some of the Google Lunar Prize teams are wanting to go to the Apollo landing sites and trample with their rovers across the sacred footprints of the astronauts. And there's nothing NASA can do about it. It's not a national park. The US doesn't own it. The US has no special rights to it. So you can do anything in space. It's going to be a wild frontier. So that's just something to tuck away there. It's going to be a little crazy. There are going to be sex hotels in space. This is a little awkward to remind you of, but every innovative technology, the internet being a prime example, the pornographers and the sex industry has been at the vanguard of it. You know, videotape, internet, you know, name your thing. And so I don't think space will be any different. So there are going to be some very unsalubrious things happening in space. And again, no regulation. There's no government agency putting a limit on it or a lid on it. I think we're going to get a space elevator. Space elevator on the Earth is not possible with current technology. What is a space elevator? In very short terms, it's a cable that you build up from the Earth's surface to a point where the centrifugal force is sufficient to hold it against its own weight. And at that point, like an Indian rope trick, it just hangs there. And then you put little crawlers, solar powered, and now you don't have to spend rocket fuel to get to zero gravity. And brilliant. This cannot be done on the Earth, but it can be done on the Moon with 1/6 gravity, now, with current materials. And it would cost, by some estimates, NASA estimates, $10 billion. That's really not a lot of money. And so companies will gather together and combine to do this because it enables them to take the next step of space exploration, using the Moon as a staging point. So you'd have your Moon base, and then you'd use the elevator to get you to zero gravity, at which point it costs almost nothing to get anywhere in the solar system. I think that's going to happen. It really could happen very soon. And at that point, you can mine asteroids. And I'll point out the top curve is the inflation-adjusted price of aluminum, and the Industrial Revolution in the modern age has been fueled by the cheapness of aluminum, which is a finite, non-renewable resource. But if you're talking about the availability of metals, precious metals, rare earths, with high commodity values and finite resources on the Earth, then a 500-meter near-Earth asteroid has several $1 trillion worth of platinum group metals and several $1 trillion worth of rare earths. And we have the technology to land spacecraft on a near-Earth asteroid and steer it into an Earth-Moon captured orbit and then mine it at our will. And there are people who are working out plans to do this. It's not happening next year, maybe not 5 years from now, but it is going to happen. And just the same, they will risk their shirts, just like the people who settled the West and were wildcatting for oil or looking for gold in California 150 years ago. They risked a lot of people lost fortunes, a lot of people died. It's the same thing. They will do this in space. So this is going to happen. And I'll just take a brief musical interlude to remind you that we are going to go to Mars, and there's going to be jobs. Be wanting some good people in about 10, 15 years. Now, some things are not going to happen, so let me just at least say things that are not going to happen. We're not going to terraform Mars and have it as a place to go if we screw up the Earth. We have to take care of this planet. The minimum time and price tag for turning Mars into a habitable world, the technology exists to do it in multiple stages, to release enough carbon dioxide to cause a runaway greenhouse effect, to melt the subsurface water, to seed it with extremophile microbes, and then oxygenate the atmosphere. It can be done. But the cost is tens of trillions of dollars probably, and hundreds of years, maybe heading for a millennium. So that's not going to get us out of any tight situation on the Earth, although it could be done. I also don't think we're going to have these wonderful space fuels. This was from space art of NASA in the early 1970s, visualizing tens of thousands of people living in centrifugally artificial gravity space wheels. And it was commissioned by NASA. And you look at this and you think, you know, what were they smoking? You know, well, it was the 1970s, and they were smoking. Even in NASA, they were smoking. So I don't know. Beyond the horizon, it's very hard to tell. So now I'm just speculating, and the last part of my talk will just be speculation. I mean, the fundamental problem is that the fuels are not good enough. Everything I've talked about, everything that's on the horizon, everything we're planning and doing is based on chemical fuel. And chemical fuel is tens of millions of times less efficient than nuclear fuel. I mean, what we would get out of a nuclear reactor. So we have to have different fuels. And there is essentially not enough chemical fuel in the universe to get us to another star at some significant fraction of the speed of light. It can't happen. That's how bad it is, unless we have new fuel sources. In fact, most of the ideas involved with traveling beyond the solar system involve not just nuclear fuel, but capturing the fuel as you go from the thin, diffused hydrogen in interstellar space and fusing that as you go along, using huge catchment funnels that are kilometers across. So designs for that exist, but we're going to have to do something clever and innovative. So we'll get our fuel from space, and every now and then there are engineering designs for new ideas. You know, warp drive, wormholes, science fiction stuff, nope, ain't going to happen. There's no engineering studies of any of that stuff. We're going to have to just gut our way through standard technology bounded by those good old laws of physics. But if you want to be optimistic, you could plot the history of human transport and see that it does actually, on a logarithmic scale, project to traveling perhaps in a century or so at a few percent, 5% of the speed of light. And I actually believe that too. I think innovation will get us towards a few percent of the speed of light in 50 to 100 years. That's an interesting number. And that's a number that this project, Breakthrough Starshot, is planning by using the combination of miniaturized technology, nanobots essentially, and huge terawatt lasers beaming power to these little nanobots attached to meter-sized solar sails to get them up to a 5% of light speed and thereby get to the nearest star system. Fleets of these things, obviously not one or a few. That's an incredibly ambitious idea that was given big public pronouncement. This is the Yuri Milner project, and other luminaries are involved in this. It's a great swing for the fences stretch goal. Why not? Get to the nearest star system with little cameras that would see if there is life on that Earth-like planet in the Proxima Centauri system. Wow, that would be amazing. Go there. It's still a two human generation project, 40 or 50 years. And if you go to their website, they actually list about 18 technical challenges that have to be overcome, especially to enable laser light to be focused sufficiently from the Earth's surface through the atmosphere to propel these tiny little targets to significant speeds. So this is just a schematic, but the technical and engineering challenges are phenomenal. But how amazing that someone put up an enormous amount of money to start working through the technical challenges. So people are doing this. They're ambitious. They're trying the hard thing. And if you can do that, if we can do that, and anyone else could do that, you have an interesting little prospect raised by Enrico Fermi in 1950. Where are they? Because at this capability, you could traverse the galaxy in a time scale of a few million years, short compared to the age of a star or the geological age of the Earth. And the question becomes, why should we be the first to do this? Why shouldn't other civilizations have sent their robotic technologies out to explore the galaxy and send the information back at light speed? Not themselves, that's too hard. They'd send their robotic proxies, as we will do. An interesting question. So let me finish with my predictions. And I'm confident of the first few, and then it gets very fuzzy, of course. We have pretty much already found an Earth clone nearby. And now the distances are large. The nearest Earth clone is already going to be between 10 and 20 light years. So it's hundreds of trillions of miles away. It's not anything we can go to easily, but the Breakthrough Starshot is a project designed to home in on that target and find out what's going on there. Is there life there? Are there creatures that we can see with a camera there? That would be amazing. So we've identified these targets largely through astronomical techniques. Something I haven't mentioned is that to go out into the solar system, to do more than just tool around in low Earth orbit, and remember, I didn't even say this, low Earth orbit is no more than half a day's drive straight up. It isn't that far. It's not really that impressive. If you want to go the hundreds of millions of miles or the billion miles to the giant planets or the trillions of miles to the edge of the solar system, you're going to need to take the human species down into a wait state. And medical technology, largely in the goal of trying life extension and also resuscitation of people who've had heart attacks or fallen into ice water or whatever, have learned that humans can actually go down into a wait state. So experiments with dogs and pigs have shown that you can replace the body fluids and or essentially take these mammals, the best models for us, into a wait state and bring them back up, not completely perfectly, but with some success rate. And these are the early stages of deciding to just pray that it doesn't happen to your dog, but that your dog isn't captured as a stray and subject to one of these experiments. So I think suspended animation techniques will mature quite rapidly, not necessarily motivated by space, but motivated by medical research. I think that the Chinese will beat us to the moon, back to the moon again, and of course if they do it and it's real, we'll have a really bitter new space race, because the US will go back. You think we won't go back? Just wait till they have their plan in place. We'll go back. I think that in about 20 years, less than 20 years, we'll have our 1,000 space tourists. Remember, we're talking about 9 now, less than 2 hands worth. So I think that will be the boom of that. I think that some of these companies, as I mentioned, will start to dust off the shelves NASA plans that were never funded. NASA is full of smart people and clever engineers. One of the NASA plans from 30 years ago is to land a mission on the European ice pack and use the nuclear plant to melt through the ice slowly, and then release a hydrobot to look for life. That could well be the first detection of life beyond the Earth. And you don't have to do all the engineering and design work, you just have to fund it. And so let me just say that Virgin does that. And maybe they get to discover Life 2.0. What an amazing thing to do. What a bargain to do it for a few $100 million. I think this is going to happen more and more in the future. I think the first off-Earth baby, an event as epochal as us leaving Africa for the first time 50,000 years ago, will happen. After a few hundred generations, a moon or a Mars colony, through the genetic bottleneck effect and the different physical environment and their likelihood that they'll use aggressive genetic engineering, will almost form a new species. So the first off-Earth species will radically diverge from the human tree once we have a self-sustaining colony. And I think that's going to start happening on this time scale, half a century. So we will have Mars colonists. We will have self-sustaining Mars colonies, not reliant on the Earth, with birth, with death, with the full life lived on that planet. I think Google, because they already own the information of the world and they're going to stretch their scope to the solar system, and they will use nanotechnology to do it, to explore and gather information in the solar system, they'll be sort of doing scientific exploration. And there's an alignment of purpose sometimes between these huge tech companies and pure research. It can happen. I think I'll give Breakthrough Starshot the benefit of the doubt and say that within roughly 50 years they will get to the nearest star system and explore an Earth-like planet. I think a little longer than that, and we'll be able to produce self-replicating probes that can do this, mining materials on asteroids or low-gravity objects to make replicas of themselves and using solar power to travel. And at that point you can propagate exponentially through the galaxy. That boots it up at an enormous level. These are called von Neumann probes after Johnny von Neumann, a 1950s Princeton professor who put the theory behind a lot of computer science that we use. And then I think teleportation, it's the only science fiction reference I'm going to make that's not totally tongue-in-cheek, but in 1995 a very important physics paper showed that teleportation is not ruled out by physics. It's not ruled out by quantum mechanics and the wave function collapsing, because we've already demonstrated entangled quantum states on transcontinental distances. So there is no fundamental physics objection to transmitting genetic information, potentially, over large distances at light speed. Now, doing it for a human organism is just such a different scale that it's almost unimaginable. But I think teleportation technology could truly take off within the time scale of a century. And so I'm not going to give you the beyond the solar system spiel, because I think that is really hard. I've said why it's hard. Space is so damn big. But I'm going to paint through Hans Wormquist, a great Dutch filmmaker, using beautiful images matched to the words of Carl Sagan spoken decades before. I'm going to give you a vision of what this will look like when we finally master the solar system.